So here is a problem. Design a DFA where input is valid if it contains at least 3 numbers of A over alphabet AB. So we have to design a DFA for the a string container at least 3 numbers of A. We know at least means at least 3 means 3 or more than 3 numbers of A. That string contain 3 or more than 3 numbers of A, which we have to find that numbers, or for this number we have to design a DFA. So here is solution. Theory. In theory we write a definition of a DFA. For definition of a DFA, go to my first lecture of a DFA. Then logic behind that problem. Input is A or B. Input is AB or alphabet AB. So output always is a yes, no. Then states. So QS, we know QS is a starting state. Q0 for A. So remember, here we have to find a numbers of A or any numbers of A. So here is a, for B, no any state. We have to find a numbers of A or contain a many what number of A. 3. We have to find 3 numbers of A. So here is a no any relation of a B in this problem. So we have to take states. We have to also take a state of a B, but it be little bit complex, make a complex problem. That's why we here is not take a state for B. We have a 0 number of a that state for Q0 for 0 number of a. Q1 state for 1A, 1 number of a. Q2 state for 2 numbers of A. Here I am write 2, A, 2 numbers of A. Q3 for 3 numbers of A. And Q4 for 4 or more than any number of A. That's why we take a state Q4. So these are the 4 states. We have considered these 4 states because we have to find here at least 3 numbers of A. That's why we take states for numbers of A. This states for Q0 state for 0 number of A, Q1 state for 1 number of A, Q2 state for 2 number of A, Q3 state for 3 numbers of A, and Q4 state for 4 or more than 4 numbers of A. So we have to find at least. That's why here the Q4 is our final state, because at least means at least 3 or more than 3. That's why we have more than 3 numbers are 4 or more than. So here is a Q4. Q4 is our final state. Suppose here ask at most 3 number. So here at the time we ask at most 3 numbers of A. So our Q3 is our Q2, Q1, Q0, Qs are all final state except Q3. Q4 is here not present when we ask at most 3 numbers of A. So when we ask at most 3 numbers of A, then this states set are present, and Q3 is a non-final state and all are the final state, because here is a ask the at most, but here is ask at least. That's why we have that is a final state, and these are the non-final state. QS is a start state. Implementation. Next point is implementation. In implementation, we draw conversion table and transition table. So first is a conversion table. It's also a transition table, but here is a conversion is possible. That's why I am call it conversion table. Input AB, QS, Q0, Q1, Q2, Q3 and Q4. Q4 is a final state. So QS A, here is a 0 number of A, 1 number of A, 2 number of A, 3 number of A, 4 or more than A. So here is a, we take A, here as A for 0, here is a no any number of A present, we take A1 upper side. So when we take A from upper side, so here contain one number of A, so we have one number of A contain a string Q1. When we take B, so when we take B not contain any number of A, so Q0 state for 0 number of A, here is a Q0. Then we take 0 number of A and upside A, so here is only A for A, 1A, so that's why Q1. And we take here is 0 number of A, 1, that's why here is a B, so B having no any number of A, that's why Q0 that contains 0 number of A. When we take an upside A, and here is a contain one number of A, 1 or this 1A, that is a 2A. So for 2A we have a state Q2, so here is a Q2. When we take here's 1A, here has a 1A, so 1A upside B, so we have a contain one number of A, so here is a Q1. 2 numbers of A, here is a present 2 numbers of A, and upside we take 1A, so here is contain 3 numbers of A. For 3 numbers of A we have a state Q3, so here is a Q3. Q2, here contain 2 numbers of A, one take from B, so here is also Q2 because 2 numbers of A, same for remaining. So Q3, 3 numbers of A upside 1A, that's 4A, that's why Q4. 3 numbers of A, when we take on B, B, so here contain only 3 numbers of A, so here is a Q3. In Q4 contain 4 or more than numbers, that's why Q4, here is also Q4. These two states have the same output states, that's why these two states are merged with each other. Here is the two state, that is a QS and Q0 having the same inputs or output states, that's why that's two are merged with each other. We have no merging rule. Merging rule says two non-final or non-final states merge with each other and two final states are merged with each other. So our transition table is after merging. This is a transition table after merging. Q2, Q3, Q2, Q3, Q4, Q3, Q4 is a final state, this is start state, Q4, Q4, this is our transition table after merging. Now draw the transition diagram for this table. Q0, Q1, Q2, Q3 and Q4. Q4 is the final state, that is a Q4. So transition table Q0 to Q1, Q0 to Q1, Q0 to Q0, Q1 to Q2, Q1 to Q1, Q2 to Q3, Q2 to Q2, Q3 to Q4 and Q4 to Q4. So these are the transition diagram for this is the transition diagram for this problem.